Welcome to this video. So in this video we are going to talk about proving irrational numbers. In the previous video we talked about rational numbers and we discovered to say rational numbers are numbers that can be written in the form P over Q, where P and Q are integers. Therefore, for irrational numbers, they can't be expressed in the form P over Q. So these are any numbers that can't be expressed in this form P over Q. So examples of irrational numbers, let's see them. Examples of rational numbers. Examples. Examples, we have this one. This is a rational number because it can't be expressed in the form. It can't be equal to P over Q. Yeah, so this means this is a rational number. We also have this one. This is a rational number also. Rational number. You also have 2 plus 7. So this is also a rational number. So let's start now proving irrational numbers. How to prove if a number is irrational. So for example, let's prove this one is irrational. So to prove this one, if it's irrational, you have to say assume this one is rational. And can be expressed as P over Q, where P and Q are integers. But P and Q do not have a common factor. So that's the whole idea first if you want to prove if this one is a rational number. So we have said P and Q are integers, but P and Q, they don't need to have a common factor. Let's rub here. We start writing. So we said this one is equal to P over Q according to the assumption. Then we are going to square both sides here so that we Q this square root here. So we are going to say square both sides. Square it. So when you square, you are going to have 5 here. So when you square, you are going to have 5 is equal to P squared over Q squared. Thereafter, you are going to say P squared is equal to 5Q squared. So as we can see here, this means that this p squared can be divided by 5 here. Since this p squared is saying to have p squared, to have q squared, you have to multiply it by 5 in order to be equal to p squared. So p squared is divisible by 5. So this is divisible by 5. So we are going to say let p be equal to 5r, where r is an integer. So this r is an integer. So you are going to replace where there is p, you put 5r. So we are going to say 5r, then you square it, equal to 5q squared. So we are going to have 25 r squared is equal to 5q squared. So you are going to divide both sides by 5. So you divide by 5 here, you also divide by 5 here. So you are going to have q squared equal to 5r squared. So as you can see here, this means that this q squared here is divisible by 5. Q squared is divisible by 5, which actually also implies q is also divisible by 5. So as we can see, 5 can be divided by q and can also be divided by p. And this actually doesn't sit well with our area assumption where we said p and q don't need to have a common factor. So it has been discovered to say p and q have a common factor of 5, which contradicts our area assumption. And hence this one is not rational, which means it's irrational. Let's put in brackets here. See, irrational. That's all. That's how you prove if a number is rational or irrational. That's all for this video. I hope you have enjoyed it and you have learned how to prove if a number is irrational or not.